Why is the Grashof number important for natural convection? Imagine a pot of boiling water. As the water heats up, it rises and cooler water sinks, creating a gentle flow. That's natural convection in action. But what controls how strong that flow gets? That's where the Grashof number comes in. The Grashof number is a way to measure the balance between buoyant forces and viscous forces inside a fluid caused by temperature differences. Buoyant forces are what make warm, less dense fluid rise, while viscous forces resist that movement, like friction in the fluid. This number helps us understand which force is winning and how the fluid will behave. When the Grashof number is low, viscous forces dominate. That means the flow is weak and smooth, called laminar flow. Think of a gentle breeze moving through a calm lake. But when the Grashof number is high, buoyant forces take over. The flow becomes stronger and can even turn chaotic, known as turbulent flow. Imagine a raging river with lots of swirling currents. This number is similar to the Reynolds number used in forced convection, where external forces like fans or pumps drive the flow. But in natural convection, the Grashof number tells us how temperature differences cause fluid motion on their own. For example, along a vertical heated wall, if the Grashof number exceeds about 1 billion, the flow can become turbulent, which means heat is transferred more quickly. The formula for the Grashof number includes several factors. It considers gravity because it pulls the warm fluid upward. It includes the coefficient of thermal expansion, which shows how much the fluid expands when heated. It also depends on the temperature difference between the hot surface and the surrounding fluid, the height or size of the heated object, and the fluid's viscosity. Knowing the Grashof number helps engineers design better systems. They can predict if natural convection will be strong enough to cool electronic devices, heat buildings efficiently, or run chemical reactors smoothly. If the number is high, they know the flow will be vigorous, and if it's low, they might need to add external forces to improve heat transfer. In simple terms, the Grashof number acts like a guide to understanding how heat moves naturally through fluids. It shows whether the fluid will flow gently or chaotically, helping us make smarter choices in designing heating and cooling systems. So next time you see steam rising from a cup or warm air circulating in a room, remember that the Grashof number is quietly controlling how that heat transfer happens.